Hello everyone. So today let's solve the problem ring road 2, right? So this was asked in the Codeforces beta round 27, right? So yeah, a Codeforces format for the, this is rated for the division 2 actually. This is fine. Let's see what the question states here. You can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. So see, this part, whatever they have mentioned in the white, actually just go through it. That's important. It is well known that Berlin has n cities from the silver ring cities. So this part. So let me summarize the question here, right? So we have been given n cities on a cycle, right? So we have been given n cities on a cycle and m new chords, right? So and m new chords in the sense coordinates. This one chords actually, sorry, not the coordinates, chords, chords. This is fine. Non-adjacent city pair. Right, so we have been given n cities on a cycle and m new chords, nothing but non-adjacent city pairs, nothing but the coordinates itself basically. Decide whether you can draw each chord either inside or outside the cycle so that no two chords cross. So we have to make sure that the the cycle, this one, what do we call, no two chords cross actually, in the sense, so we have to decide whether we can draw each chord either inside or outside the cycle so that no two chords cross here, meaning endpoints may coincide here. Even though endpoints may coincide here, it's not a problem. Yeah, so if possible, then we have to output for each chord I, right? So in the input order, nothing but I inside or O outside. Otherwise, we have to print impossible. Otherwise, we have to print impossible. Chords cannot lie on the ring. Again, chords cannot lie on the ring and cannot intersect the ring except at their endpoints. Chords cannot lie on the ring and cannot intersect the ring except at their endpoints, right? So also they have given, if possible, we have to output for each chord I, right, inside or O outside, right? So I in input order I inside or O outside, right? So otherwise we have to print impossible. Otherwise we have to print impossible. Yeah, chords cannot lie on the ring and cannot intersect the ring except at their endpoints. So this is the question basically. This is the question. So let me come to the input output part here. So see, n we have been given 4 and m we have been given 2, right? So this one, n we have been given 4 and m we have been given 2 actually. N is nothing but the number of nodes here. Number of nodes we have 4. See here. So this is the edge, right? So 1 to 3 and 2 to 4. So let me draw the graph for this. 1 2 3, let me write here, and 2 to 4 actually. Yeah, 2 to 4. 1 to 3 and 2 to 4. These are the edges that they have given here. So this is fine. Uh, Here, see, this is the input out. This is related to the input output basically. Here in this sense, the output that we need to get here is I and O, I and O respectively, right? IO actually. Yep. Now this is nothing but the N and this is nothing but the M, right? So basically we have the edges 1, 3 and 2, 4. This is fine. So let's discuss the idea, man. So let me delete this one entirely. Now we have the idea on the this one question as well as the input output. Now let's discuss the idea, meaning let's hop into the approach part actually. Before hopping into the approach part, so let me tell you, we will be going with a bipartition, right? So bipartition, nothing but the bipartite two color. We call this one as bipartite two color, right? So we'll be going with a bipartition approach, right? So idea, what's the idea here? Two chords cross on the circle. Two chords cross on the circle only if their endpoints are interleaved around the circle. Only if their endpoints are interleaved around the circle. So we will build a graph where edges are adjacent, right? Edges are adjacent. So this one I have showed you 1 and 3. So they have given simple one man here. 1, 3 and 2 and 4, right? So here what happens? So we are considering this one for the approach. First example for the approach here. So we have to build a graph where edges, chords, nothing but the chords actually are adjacent when they cross. We need to two color that graph inside or outside, nothing but the bipartition. Yeah, nothing but the bipartition, or this one you would have heard the this one term bipartite graph. Usually we say this one bipartite itself, right? So this is fine. Now this nothing but we'll be going with a approach by partition. So here, let's see how we can do this. So what we will do, so we will normalize the endpoints to order. So let's go step by step so we understand this one clearly. So we will normalize the endpoints just to order this one a less than b, just to order a less than b. For example, 1 comma 3 and 2 comma 4 remain 1 comma 3 and 2 comma 4 itself, right? So this one 1 comma 3 and 2 comma 4 remain 1 comma 3 and 2 comma 4 itself. Yeah. So again, we'll normalize the endpoints to order a less than b, right? So a is less than b here, 1 comma 3 and 2 comma 4. In this case, it for this input, it remains same. So a he is less than b here, right? 1 comma 3 and 2 comma 4. It remains 1 comma 3 and 2 comma 4 itself. Next, this one, let's move on with the second point here. We will check the crossing. When I say we will check the crossing, so 1 comma 3 and 2 comma 4, the edges that we are considering here. So this one 1 comma 3 and 2 comma 4 are interleaved because one is we know this one from the previous step, one is less than 2 and this one 3, sorry, yeah, one is less than 2 and 2 is less than 3 and 3 is less than 4. That's what we have, 1 comma 3 and 2 comma 4, right? So we'll check one is less than 2 and this one, what do we call, 2 is less than 3 and for this one, what do we call, 3 is less than 4, right? So yeah, so here 1 less than 2 less than 3 less than 4. So this one, this is fine, right? uh Yep. Now we will add an adjacency between chord 1 and chord 2, right? So this is fine, chord 1 and chord 2. So let me delete this one. Let me delete this one. Let's move on with the third point now. So third point here is we must assign the different sides to the crossing chords, right? So we must assign different sides to the crossing chords, meaning, so we have to try to two color the adjacency graph, meaning for that we will be starting the DFS from the chord 1. So we will be making use of the DFS here, right? So we'll be making use of the DFS. So DFS from chord 1. So we'll be starting the DFS from the chord 1 that gives color 0, right? So that gives color, starting the DFS from the chord 1 that gives color 0, right? Color 0. This one, in simple terms, this O actually, in O, right? O. Then chord 2 must give the color 1. Then chord 2 must give the color 1 actually. Then chord 2 must give the color 1 actually. This is fine. Yeah, no conflict arises here. So we have to output the characters in input order, right? So this one will be chord 1 equals 0 or O, however you this one you consider, and chord 2 that is equivalent to I. Chord 2 that is equivalent to I. We have to print IO here, right? We have to print IO accordingly with the input or the example that we considered. So output that we got here is IO, right? After performing the DFS. So the output that we got here is IO, which is equivalent to the output that they have mentioned for the example one within the question, right? So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? So the time complexity would be big of m square here. The time complexity would lead to big of m square or m to the power of 2. So this one, we compare every pair of chords, right? Implicitly in the DFS adjacency loop, basically. So we'll be going with the DFS. So we'll be performing the DFS. We compare every pair of chords implicitly in the DFS adjacency loop, right? So overall time complexity would quite obviously lead to big of m square. And what would be that space complexity? Space complexity would lead to big of m plus n. The space complexity would lead to big of m plus n, right? So which is big of n with n chosen as an upper bound for the arrays, practically big of m actually. So we can just consider this one big of m plus n actually. Yeah, this became basically in simple terms. So we'll be making use of the arrays a, b, column, visited, scale along with the m. So overall space complexity, we can just consider m, or we can just go with the big of m plus n as well. This is fine, man. The time complexity and the space complexity for the code that we'll be writing in the future would be big of m square and big of m plus n respectively. Now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code, right? First, we will be making use of fast input and the output. So let's import the input output package. Also, let's import this one. What do we call utility package as well, right? So I'll just go with util dot star. So this is fine. Next, let's go with the class. Let me go with class name main. Yeah, so you can just go with any class name here. So that's relevant to the question, right? So this is fine. Within the class, main class, first, let's go with the initialization part. So let's go with the large array bound initially. Safe upper bound for the M actually. So I'll just go with here static final int. So I'll just go with n here. This one, let me go with 10010 according to the constraint size, right? Large array bound basically. We can just call this one large array bound. So also we have to go with the a comma b. This one, what do we call endpoints along with the column, right? So this one I'll just go with static int a equals new int of size n. Also b equals new int of size n along with the column equals new int of size n. Yeah, now let's do one thing. Let's go with the visited markers first for the DFS on the card. So I'll just go with here static boolean. This is fine. Visited equals. So this one will be new boolean of size n. This is fine as well. Now let's do one thing. If true, let's go with a conflict detected, and if it is so initially it will be, let's set this one to the impossible, meaning let's make use of the flag. If the flag is true, then the conflict is detected, right? Then the basically conflict detected, then we have to go with the impossible. So that's what I meant. So first initially let's set this one to the false actually, not the true. So I'll just go with static. So this one will be boolean. Let me go with a flag. Let me assign this one to the false. Initialize this one with a false. Also, we have to go with the n cities and this one m number of new roads, right? So this is nothing but n and m we have to initialize. So this one will be n and m respectively. Now we have to perform the DFS one. So I'll just go with the static void DFS of the parameters here p as well as the c. So this is fine. So within this method, first if this node hasn't been visited yet, so I'll just go with not of visited of p. If the particular node hasn't been visited yet, then we have to initially visit that one and mark that one as visited, right? So I'll just go with visit of p equals initially. Let's set this one to boolean value true, and also column of p, let me set this one to the C, right? So now let's move on with the this one iteration. Nothing but we have to iterate all the codes to find those crossing with P actually. So I'll just go with for int I equals 1, I less than or equal to M. So did I press insert here? I less than or equal to M. Let me go with I plus plus. So within the for loop, let's go with a simple if condition. If A of I, if A of I not equal to A of P, A of I is not equal to A of P, and B of I, if it is not equivalent to the B of P, B of P, what we need to do, we have to ensure not sharing both endpoints exactly, right? So we have to check if the chord P and the chord I are interleaved, right? So they cross on the circle, right? So let's write the simple if condition for this. If, let me go with A of P here, less than A of I, and what if B of P, if it is greater than A of I, it is greater than A of I, and B of P, B of P, if it is less than B of I, if it is less than B of I here, this is fine. If it is less than B of I, or so let me go with here, again, A of I, yeah. So this one, if it is less than A of P actually, of p, and again b of I, if it is greater than a of p, again a of p, and also b of I, if it is less than b of p, less than b of p, then let's do one thing. So this one, let me move this bracket to here. This is fine. Let's open the flower bracket here, basically. So now what shall we do? Let's go with the, let's recurse actually. Recurse meaning, so neighbor must get the opposite color, meaning we will be make, or let's toggle using XOR here. So that will be the best thing to do. So I'll just go with DFS I comma C XOR 1. Yeah, C XOR 1. So let me come out of this one entirely. Now let's do one thing. If already visited but the color mismatch, then there will be conflict, right? So then there will be conflict basically. Right. So how can we write that one in the form of code? So let me do one thing here. So let me come here. I'll just write else if here directly. Else if C not equal to column of P, column of P actually, then let's set the flag to, let's set the flag to. So let me come out of this one entirely. Now let's move on with the main method. So this is fine. Remove this one also. Let's include here throws input output exception. Input output exception. Right. So this is fine. Sorry. Just give me a second here. So I'll just come here. Let me paste this one. This is purely related to the input output buffer reader, string tokenizer, and NNDM. So this is fast input. We have to read the first line. So we're making use of the string tokenizer here. N and M are nothing but we have to pass this one. Integers, right? Both 4 and 2. So this one and M. First line basically. Yeah. So this is fine, I believe. Next, what we will be doing actually. Um, let's go with the iteration part. We have to read each of the M chords, right? So this involves one based indexing, not the zero based indexing for the chords. Yeah. So we have to read each of the M chords. Let's move on with the iteration. So this one will be for int I equals 1, I less than or equal to M, so I plus plus. So within the for loop, what we will be doing, let's go with the string tokenize equivalent to new string tokenizer of buffered reader dot read line. So this is fine. Yeah, now let's go with the a of I equivalent to integer dot percent. So this is fine. String tokenizer dot, let me go with the next token. Yep. So same thing, let's do the same thing for the b of I as well. Yep. So let me come here. Instead of a, let me change this one to b. That's it. Yeah. Now, oh, this one we are making use of the one based indexing, right? So let me give here minus, sorry, we again have to convert this one to zero base. So let's go with the minus one. Initially, we went with the one based indexing. We again have to convert this one to the zero base. So let me give minus one here. This is fine. Now, so let me normalize so that a of I less than b of I will be consistent crossing checks actually. So for that one, let me write the simple if condition here. If a of I, if it is greater than b of I, then what shall we do? So within the if condition, I'll just go with the int tmp. Let me assign this one to the a of I. Now a of I will be equivalent to b of I. Then let me give here b of I that is equivalent to tmp. Mm. Yep, so this is fine, I believe. We are just swapping the endpoints out of order, right? So let me come out of this one entirely now. Let's move on with the iteration again. So because we have to run the DFS on each component, right? So uh, let me go with for loop here. Int I equals 1, I less than or equal to M. So this will be I plus plus. So let's right? The simple if condition, if not of visited of I, then what we need to do here, let's run the dfs of I comma 0. Simple. We are just making use of the dfs helper method within the main function. In simple terms, we have to run the dfs on each component, and we have to start with the color 0 actually, accordingly with the approach that we discussed, right? We have to start with the color 0. This is fine. So if the coloring conflict found anywhere, then what we need to do, we cannot place roads without intersection, right? So then we have to print impossible. Yeah, that let's do. If of we have written flag, the boolean this one, right? So if of flag, then let me give a system out println. Let me give impossible within the this one. Let's print impossible. So this is one of the criteria that they have given in the question. After this, we have to terminate from here. So let me make use of return, or we have to exit from here, right? So let me give exit here, or the sorry return here. Next, we are left with only one thing. We have to build the output string. So I'll just go with here string, not string tokenizer. Let's go with a string builder, right? Let me make use of variable sp new string builder. This is fine. The next one is, let me go with a for loop. So this one will be for int I equals 1, I less than or equal to m. So this will be I plus plus. So this one will be string builder dot append. So this one will be column of I. If it is equivalent to 1, then let's print I. Else, let me go with a, oh, this is fine. Yep. Now let's do one thing. We have to print the result. So I'll just go with system out println string builder variable sp. Right. So this is fine. This is it for the code. We are done with the coding part. So before checking the code with the different input out, this one different inputs are the examples. Let me copy paste the signature starter template. So let me paste it over here. Yeah. I'll just come here. Let me copy this one. The output that I need to get here as IO or I0. Hmm. Column. Oh, this one I have given double equals here. Sorry. 1 second. Where is it? Line number 24. We are getting the output. OI. This is also fine, I believe. Yeah, this has to work. Let's see. So output. So let's go with the second input here. Output we need to get here as triple O. Let's check the same. Yeah. This is fine. Order doesn't matter, right? In the question they have strictly mentioned. So let me come here. Let me hit the submit. The submission part. Let me paste the code and let me hit the submit button. So let's wait for some time. Let's wait for some time, right? Yeah, yeah. In the toast, it is showing accepted, right? So whatever the code that we have written works absolutely correct. The verdict that we got here is AC or accepted. So this is fine. So we have went with a pure this one month bipartition actually here, right? So we have made use of the DFS mainly to solve this particular problem. That's it. Yeah, this is nothing but the bipartite graph, or you can just call it as bipartition actually. Yeah. So this is it actually. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.